Okay, my name is Viktor Sehr. I'm from Stockholm, Sweden. And I'm here to speak. I can start with myself. I worked with Mentis, a company in Sweden which make medical simulators for practicing surgical procedures for doctors. It's quite big in Russia, I know. When you made a bug in that simulator, you had to restart it. So that's not so dangerous. And this is how it looked. It's a physical machine that you use. And then I worked mainly with the computer graphics part of it. I worked at Propeller Heads, which makes music software. A lot of artists use it. I don't know exactly whom. When we had bugs in this software, we got glitches in audio, which is not very good, especially if they use it live or if they do a recording. So it was very important to do low latency code, no allocations, no nothing in the ending part of it. And I also worked at Research, where I made the computer graphics. It's a company that makes cancer treatment software, and if you screw up there, people die. So you have to be very careful with assertions when working with that. Right now, I develop a game for Android and iOS on my own with my brothers, actually, but I do most of the work. And it's a skiing game, and we have come maybe half of the project. We'll see. And please buy it, because I need money. And I also write a book in C++ for Pact Publishing, and Sergey here is my technical editor. He's doing a good job, and please buy that one too, and one for your mother. Let's start with C++ a little bit. What I like about C++ is that you can do pretty much, actually my idea was that they're going to pop up when I speak, but this was something in the exportation to PowerPoint from Google Drive, so you get everything at once. Do I have a... yeah, you can write everything from graphic user interface down to the high performance in the same code base. In almost every company I've been at, you had to, you always use like a Java or C# for wrapper, and like half of the development time was wrapping between C++ and the Java or whatever it is. Not funny. And it's platform independent. That's very good. I like the language because it's very robust. It has val semantics, and it's not like Java and C# where everything pretty much is a bunch of shared pointers, pretty much. You can write const for functions and for variables, which makes it much easier to debug. And you can create good libraries, even though it's quite hard to create libraries. Even new junior programmers can use libraries, and it's hard to misuse them if you make them good. And C++ is getting better every year, and now it's quite good, I think. Memory management and all those stuff, you don't use it anymore. And also the verbose syntax, it's pretty much a thing of the past. I don't like the verbose syntax. I want to write exactly what the program do and nothing else. But it also, of course, has some disadvantages, which is mainly the compile times. It takes hours and hours, and I don't like the manual labor. You know, you sit and you forward declare and you do pimpel and whatever you do just to reduce compile times. You shouldn't do that, but you have to. But it's not a job for a human, it's a job for a computer. The code completion, even though I like Visual Studio, the code completion, and the IntelliSense, it's not as good as it could be. And it, of course, has very few built-in libraries, but that's both an advantage and a disadvantage. I think the library handling is horrendously complicated sometimes. To import a library, you have to build it, use the same build parameters and whatever to get a lib, which you then use, and then you have problems compiling, and it takes too much time. I like header-only libraries, but they unfortunately increase the compile time very much. On the positive side, modules are on the way. They are way too late, but they are coming, and they will hopefully fix these problems. I'm going to start with my number one surprise when I started working with C++ professionally, and that is that code bases consist of spaghetti code, even professional. I thought everything was going to be perfect when I started working at like cancer software or music software that's been going on for 20 years, but it is not. It's copy-pasting all over the code. You can find the same piece of code over here and there, even in professional code bases. And there's unbelievably complex procedures for adding like an image resource. It takes like an hour because you have to add it everywhere. It shouldn't be like that, but it often are, even in professional code bases. And you can find initialization code, for example, for OpenGL or for whatever, for audio drivers that's like copied straight from the internet, from some Hello World tutorial, even in professional software. And I think this is the worst thing. You sit and you debug and you debug and debug. It takes time and it's slow and a lot of time where you're not producing code. And it's flooded with bulk code, of course, especially in C++, which doesn't actually add anything. It's code that a machine could do, like the equality operator, the O-stream output, etc., etc. And I don't understand how so many programmers can accept to work in slow the big builds, which takes a lot of time. So I'm gonna give you some pointers and some ideas that I thought are valuable using when creating your code base to be more efficient and write less bulk code. And also my skiing game has a lot of this. So, what do we want? We don't want to waste time to recompile, restart all the time. We don't want to waste time to develop in pure debug mode, which is really slow unless you have a supercomputer. And we want to detect bugs as soon as possible, and we want to have as much information as possible when we get to the bug. I will not talk about build systems or anything like that. I will talk what you can do purely from C++. First of all, I would recommend, because some projects and companies only use two builds. They have the debug and the release. Not good. The debug is too slow, and the release has too little debugging information. So I really recommend to have the produce build, which is something in between. It's quite fast. It still has UR asserts, but it doesn't have like the SDL asserts or whatever the runtime the compiler does when you run the bug. So you can be pretty efficient in it. And I will show you some, I think, the assert macro I'm going to start with. The assert macro is very important. It's your main bug scout, and I think the reason that software is still as buggy as they were 20 years ago, or were as good 20 years ago as they are now, is because they used assert and we use assert. And regardless of unit tests and Scrum and whatever happens, the assert is still the most important thing for testing for bugs and making your code good. And I'm going to show you how a little trick to store the values in your logger when you have the assert. No, this was up. Yeah, I go straight to this. In the beginning, my idea was to live show you this, but as it showed, I had to use another computer, so I couldn't do that. So I just copy-pasted the results back, and that's what I did now. And my example is that you can write an assert macro that works like this. I have those variables, and I have the asserts, and I can then in the assert macro expose the values, which is very invaluable information when you debug and when you get the log. So in this case, the first, you see you get 8, 12, 13, 14, 15, and the values are printed out. And the macro is made out of an expression fetcher, which works like this. It takes an expression, it makes a fetcher, what I call it. It stores the values. And then you fetch from the left. I use the person symbol because it has very low precedence, so it comes before a lot of other operators in C++. And by using this, when I evaluate an assert macro, I grab the value, I string stream it, and I push it to a vector. And in that, by using that, you can get the assert values out in your log without going out of C++ or doing anything else. Let's see, what did I put? I also think it's important that it's very easy to append messages to your assert, and you should write it. You should not have code that looks like this, which is pretty much a big assert. You should have, the easier you make it, the more information you'll get when people write asserts. So you should have a operator like this going from left to right, so you can add messages in like seconds. Contract programming. I don't know how many of you use this, but it's the idea is to provide a debug validate function for every class, which validates that your class is valid. And it should always be valid when you're entering and you're exiting a member function. It can be invalid in between, but always then. And it may not call any other member function because you will get a stack overflow because they should call the debug validate. And it's accessed via macro, so you can remove it in the release builds. And this is an example of how you can implement a class like this. You have the debug validate function, which in this case asserts that speed is higher than 0 or 0. And then this macro, I will show you how it works later, but in this case it only evaluates once, and in this case it evaluates, as this is a non-const function, it evaluates at the beginning of the function and at the end. And the macro is implemented like, first I have the scope exit, this is just a bulk code. And you implement it like this, and you utilize the type traits to check if the class is const. If it's const, you let the scope exit execute the function at exit as well. And if it's a const function, this won't get evaluated, so you only run it once. You don't get that bad performance penalty. And there's another nice thing about debug validate is that you can use it to detect if you have written a bad function. Because if you write a function that does not follow these rules, your coworkers won't understand the class, and you think you should redesign. So it's a good detector for junior programmers that your classes are good. And this is an example of a bad, it's quite a complicated example, I know, but this is the example. This is some sort of node class. I'm sorry it's really big, but my point is, this is, if you look at the debug validate, it validates as if a node has children, it may not contain items, so only the leaf nodes may contain items. And here we do an add item function, and this is the very bad function because it splits the nodes, and that's all it does. So when you run this function over here, the debug validate will not be okay. The invariant will not be okay because you will still have children in it. So it's time for redesign. So that's a good way of designing your code like that. I'm going to show you reflection. As I said, a lot of problems in C++ is that you have to write everything all over again, and you get half-assed classes and tuples and stuff because you don't have the time to write reflection. So what you do is you don't have the time to write all the operators I meant. So what you can do is you can do some simple way of just adding reflection. I'm going to show one example, but there are other examples of how you can do it. This is how complicated a very simple class, how to look because of C++ and because you don't use reflection, and it's a lot of code to write just for quite simple functionality. What we would like is to have this small class. And as you see, there are other ways of implementing reflection, but what I do, I just return a tuple which has references to the member variables. So how do we automate this? First, we use it's quite a secret method in C++. It's just exists in the experimental. But what it does is it checks. You can use it to check if a class has a member, and the member here is reflect. So it checks that this is valid code. And if it's not valid, it returns false at compile time, and if it is valid, it returns true. So what I do then, when I have the reflect, is I overload the equals operator, the not equal, the less than, and the streaming operators. So what I do is I check, this is a global overload, so if the T, the template, has the reflect member, I enable this function and I do everything for this as well. I have to use a tuple for each to iterate through the tuple, of course. And with this in place, you get instantly away with all the bulk code you usually write. For example, here I have a fish class, which I create like this, the fish class I showed you here. And then I have, this is the output. I output the shark and its weight, the other shark and its weight, you see it correct, salmon. I can do the comparison, which returns true, which is 1 here, and false. So I would really much recommend you to use some reflection mechanism so you don't have to write all this bulk code and you get it written for you. And as a final note on reflection, don't compromise. Don't do like this because you want the equal only to use the weight. Then you don't reflect. You don't do like this. Either you reflect it all or you reflect nothing. You write your own operator equals operator. When you're building your code base, it's important, I think, to differentiate between what is library code and what is business logic. The library code is what should contain all your smartness or your C++ knowledge, everything. And the business logic, this is, I don't know if it's a better word, but the business logic is what you use to, if you make a game, the business logic is the enemies, the weapons, the levels, etc. And it should be very clean. It should more or less resemble a scripting language. Oh, I thought I had more there. Okay. So this is an example of how we should implement business logic. Can anyone see how can we define this? This is the antler, by the way. I didn't know that English word, and this is the moose. Does anyone know how to implement this without adding a copy constructor? It's a simple class. It's a moose. It may have an antler, it may not. And you can return the antler, you can remove the antler, and you can set the antler and ask if it has an antler. And we don't want to specify a manual copy constructor. Come again? But if you use a pointer, then if you copy the class, the pointer will point to the same antler. No, the same problem. If you copy the moose, you will still have two mooses pointing to the same object, to the same antler. Yes, exactly. That's where we're going. But before I come to optional, you can actually, this is just a trick, but you can actually use a vector or something that has the copy constructor. But of course, you shouldn't do that nowadays. You should use optional. Perfect. Back to where I were. Stepping backwards in debugger. When debugging code, you wish you could step backwards in the debugger to find the actual bug. You cannot step backwards, but you can write your code to make it almost possible to step backwards. The simple trick, and I think you should do it, is to declare all variables const and not mutate variables. Of course, for optimization reasons, big objects like vectors or containers cannot be mutated all the time. It takes too long. So, this is just a simple example I got from a code base. If we would, for example, have a problem here and assert shoots, you can go through all the variables and see the value, and it's almost like stepping backwards. It's a very good thing for debugging code, so I recommend you to use it. Do you see what I mean? Good. Pure functions. I really recommend to use pure functions. They're always good design, and if you don't come up with any other way to design something, just make a function. I'm not going to talk that much about it. There's a lot of theory going on about functional programming, but there's one advantage that people haven't mentioned and I want to show, and it's that you can use them to validate. If, for example, you have a code that calculates the distance between a point and a rect, and let's say we had old code here, which worked but was slow, and you wanted to optimize the code. So let's say this is the optimized code. You can use the old code in a macro like this, and you can verify your optimized code against the new code. So you get whenever you run this code, you get it verified in a good way. If you knew it worked before, you don't have to do. You can do, of course, unit tests, but this does it for every invocation of this line. So it's a good way to utilize. And if you look here, I use a lambda for the old expression, and to instantly execute a lambda, I use the parentheses there. So where were we? Wrappers. If it's something I can recommend, it's using wrappers to wrap things in your code base. It's a good way of communicating with other coworkers about what your intentions are, and it's clear and it can't be wrong, instead of using variable names or whatever you would use. And you should wrap almost everything, even the STL algorithms. And I'm going to show you some example. A non-empty container. If you think about it, empty containers are often like null values. A lot of algorithms don't accept empty containers, and you can be very explicit with that by wrapping, let's say, for example, the mean value. This is an algorithm that calculates the mean value, and it can't do it for an empty container. So instead of asserting that, you can straight use the non-empty wrapper, which simply wraps a container. This is a simple example. And when you write your algorithms that don't accept non-empty containers, you use this type instead of just a clean type, and you get a nicer code base, which tells you by the type what you want to use, what you need to use. Another wrapper example is wrapping the range value. I've seen people doing asserts for their integers or floats all over that are not above something, not below something. And I would recommend you to wrap them straight away. Saves a lot of time and the code base gets a lot more robust. C++ has this overloading opportunities. You can make them work almost exactly like the wrap type, the integer or the float, but you get the safety because in debug mode they will assert that you don't go out of range or whatever problem you have with them. And the wrappers has become very good with lambdas because you can invoke code from the scope straight into the wrapper. This is, for example, a simple wrapper. It's here just to show how you invoke code using a lambda. This is a synchronized value. It's a very slow version. It uses a mutex. It could probably be a lot better, but it's just an example. So what I do is I can create a synchronized a vector which is synchronized. As I said, it's slow. But by providing these two functions, mutate, which mutates the wrapper, and observe, I can very easily modify and change the synchronized container in a safe way without getting runtime, what you call currency, problems with threading in an easy way. And my point is you can even use a wrapper which returns a value here, and the function here, as it returns whatever the functor does, this even works with void functions. It returns, you can use it straight away. It's a good way to use lambdas with wrappers. One problem here is I can't make the observe function const, not pure const, because I need to mutate the mutex. You should also wrap the STL algorithms. I think it's stupid to use begin end in your code base. It's very simple to wrap them, and you make it a lot smaller. There are, of course, boost range, which does this for you, but it's also there are a few missing algorithms in STL that you can add to your little own wrapping library, like contains find or fail, which fails if you can't find a value, or index of, or whatever you feel is necessary, so that you don't use several. You get less code in your business logic, and you move the code to your wrapper library. That's it. Any questions? Yes? Come again? Yeah, they should be available.
The question, if you can download the slides from the internet, yes, all the slides will be available right after the event, in 2 weeks.
I have all the code in a CPP file, and I will put it online, so you don't have to retype, because these code are all images. Any more questions?
So you say about function good assert. What do you mean about default assert in a C++ library?
The default assert is of course good, but using a macro, and you can store the values and append messages, because the assert which comes with C++ is more made for when you are debugging in Visual Studio. Mm-hmm. But you get a lot of bugs when testers run it, and those bugs are usually logged. And the point with having a good assert macro is that you can get good loggings of what got wrong.
Mm-hmm. Thanks.
Еще кто-нибудь?
Thanks for speaking. What is your opinion about libraries which help to analyze crashes, like Google Breakpath or something similar?
I haven't used that so much, but of course they're really good. This is just like a complement to that, to show what you can do in your C++ code base instead of going to build system and libraries and crash reports systems and such. So I like them. Very good.
Thank you.
Thank you.